We forgot to hit record. We're just going over answers.
YouTube fans.
Yeah. Yeah, so all you.
All 12 subscribers.
Hey, it's like 28 now or something, you know?
How much subscribers does Diamond have?
Well, he's
I'm gonna tell him
he's
that.
one of my subscribers. So.
Is he?
Yeah, he's gonna see it. Here, you talking crap in the background.
Diamond is I'm just kidding.
Your best friend Brenda there.
I told him in front of his face and he said. I'm like, Mr. Humming's the best teacher ever.
Yeah. Not feeling number 4?
Nope.
Light travels at a speed of 300,000
Yeah.
kilometers per second. Those kilometers over seconds, right? Uh-huh. How many kilometers does it travel in a year? So, what do you don't even, if you just know units, you're good. You want your answer to be kilometers, right?
Yeah.
So how are you going to get rid of the seconds?
Multiply.
Multiply by seconds. So all you have to do is figure out how many seconds are in a year.
Did you finish your package?
Oh man, you totally skipped everything else.
Or you could just go,
I went step by step.
yeah, I go step by step too. But I'm like,
I went
what do I know? I know there's 60 seconds in a minute.
Just
Yeah.
I know that
easy?
one.
No.
So I'll go 60 seconds in 1 minute. And you might be like, well, why'd you put it on top?
So they cancel.
Yeah, so that they cancel. Well, now I got to get rid of minutes. Well, I know there's 60 minutes in an hour, so I'll put 60 minutes on top so they cancel. 1 hour on the bottom.
Is that like really just like how you
Really?
do this?
Yeah. And then there's 24 hours
in a day.
in 1 day,
And then 365.
and then 365 days
And then
in 1 year, unless I leave here. And then, so if we do all of our canceling, won't my answer be kilometers per year? And that's what we wanted. How many kilometers does it travel in 1 year? So you
yes.
Dang.
9.4608 times 10 to the 12th kilometers per year, or 9,000 whatever.
I just put 9.4608
Hundreds,
equals.
hundreds, thousands, millions, billions, 9,460,800 million.
That's a nice number.
Big.
Very nice.
Would it have worked if I did 300,000 times 60 and then times 60 and then times 24 and then times 365?
Yes.
Okay.
Yeah, that's basically what it did.
Because I was going to do that and then I didn't.
Or you could do it like I said and just figure out how many seconds are in a year and just do that by like your calculator and just and then just do it one operation. That works.
Less chance to mess up.
Okay, you ready for number 5?
Yeah.
Who got an answer for the left approximation?
For B?
10 eighths.
10/8, also known as 5 fourths, also known as 1.25. You're all right.
It does?
Yeah, I didn't even know what I was doing. Is that A?
That's number 5.
No, really. Hey.
Oh, A, B, I don't know.
Yeah, because I think it is.
A is just draw it, isn't it?
Yeah.
Yeah.
It's just graphic.
So that's B?
That's A, drawing it.
Oh yeah, I did
Left-hand
get that.
approximation.
I like drew it wrong, but still got 1.5.
Oh, because you probably did the right hand one, and there are the same ones probably.
Like this.
That's the left approximation, that's the right approximation. If you do the left, you start at each interval. Well, like this one, if you're like, oh, I'll start at 0, well, I don't go up. So I start here, I go up, I hit it, up, hit it. You use the left side of the rectangles for your heights. On this one, you use the right side of each rectangle for your heights.
You got 5 fourths?
So you do get this.
You get the same thing on this one, yeah.
Dang.
Well, either way you do it.
I got 175 for the next, for RRAM.
175?
Yeah.
The 1.75.
Like, yeah, 1.75.
Oh. Right? Any do you understand how to figure out the heights and everything? Feeling it? Heard you say that before.
Me? Where?
Probably right here. graph it. You wanna graph it? Put in some points, and I said to do, it told you to do 4 equal subintervals, so that tells you each one is 1/2 long, because you're only going from 0 to 2. And then if you want the left-hand approximation, each box, you're like, okay, I'll start on the left and I'll go up till I hit the function. Well, here, there's nothing, because the function goes right here, so you don't go up at all. So there's no box here. So then you go to this one, you go up to the left until you hit it, and you're like, well, how high did I go? Well, plug in 1/2 for x, and that'll give you the y value. Plug in half for x, you get 3/4. Then you just go over, and then this one, you go up till you hit it, boom. Plug in 1 for x, it'll give you the y value. Well, then you go to the next one, use the left, and you just go across until you're done. And then just find the area of those 3. Remember I told you just do 1/2 and then add them all?
Yeah.
Yeah, I thought I was gonna mess up on that part, but I didn't.
But I didn't.
I wrote this here because this is actually what you just did.
What is that?
That is, it's an integral. I almost said integral.
Integral?
I'm saying it wrong.
I don't think I can say it either.
Integral. There we go.
Integral.
Integral.
Something
Integral. Integral.
Integral.
That little squiggly line means find the area under this curve. This curve is this is f of x from 0 to 2.
Plebe.
B or
Plebe. Plebe. Plebe.
Oh, I got it. You said anything
You have an important AP meeting at lunchtime today.
I wasn't actually planning. I really wasn't.
I've delivered the message, that's all I was told.
Because, okay, so I'm like VP, so I don't do anything. It's mainly like president who signs off things, and then business manager. But just, never mind.
This just means find the area under this curve. Well, we'll talk more about this notation later, but that's what you did. From 0 to 2, the area under the curve is 5/4. So you're gonna love this. You're gonna see that a lot. So that's the left hand. Right hand, it ended up the same, right? No. You do the midpoint one.
Yeah.
That one came as drummer recommended when I watched this video.
There it is. 11/8.
I didn't get that.
What do you got?
Which is,
1.375. I think.
I didn't get that. What did I mess up?
I knew that was wrong.
Plug in 1/4, you get 7/16. Plug in 3/4, you get 15/16.
Oh, that's what I forgot to do. I forgot to do the half.
Oh, you forgot to plug in the
Yeah.
midpoint,
Yeah.
right? Because that's what it is, it's midpoint. So each box, right, they're all still half wide,
10/8.
but then you have to go to the middle of it and go up till you hit the parabola. Go to the middle of it, go up till you hit it. Go to the middle, go to the middle.
So yeah, I'll verify it right if I remember.
If you plug it in, that's what you get, and if you do all the fraction work, 11/8.
No, I think it is. I just forgot to plug in the half. For like when we had them together. That's the half I forgot.
Yo tengo la Only like 2. Examen jueves o viernes. You wrote that? You know Spanish too.
Hit, stop. Take it. Okay. So there's 3 problems on here for your homework. You haven't seen how to do a table one yet. You've seen how to do, this is just like last night. You got a function, and it's just approximate the area between the curve and the x-axis, so it's the same thing. On the interval 0, 2, same thing. 4 rectangles, 4 equal subs. It's the same thing as yesterday's homework, it's just a different function. So you need to be able to draw the picture over the interval 0 to 2. So it is what it is. Plug in some points, figure out what the picture looks like. I'm not going to help you with that. This one you should know how to do. Left, right, middle. The ones with the table, we haven't done that yet, so we'll do one example. I got a different one right here. We'll do, let's see, this one. This is not on your paper. It says using right and left approximation with 6 equal subdivisions, estimate the distance traveled, maybe I don't want to do this one. Oh yeah, we'll do this one. Over 0.3 if the velocity of an object at half-second intervals is this. So when it's a table, it's kind of almost easier.
Because it has everything.
It's got everything for you. Yeah, you can draw a picture if you want. So I would just draw like, I know all my I know everything's positive here, so all I need is this. And it gives me t values, half-second intervals up to 3. So I would just be like, here's 0. Here's go 1, 2, 3. And then it gives you some values for the velocity. Right? So at 0, 0, 0, there's a point. At 0.5, you're at, I can't get both of these on the screen at the same time. 0.5 is 12, 18, 20, so I'll just be like, here's 20, here's 10. Huh? Oh, I'm just plotting points. So at 0.5, I'm at 12. And at 1, I was at 18. And 1 point, I'm just doing this to get an idea. 1.5 was 20. 2 is 14-ish. 2.5 is 20 again. And 3 is 20 again. Okay? So it gives you those points, and then it just says, using right and left approximations, 6 equal subdivisions. Well, there's already 6 of them, isn't there? You see the 6? 1, 2, 3, 4, 5, 6. They're already there. So now just estimate the area under that curve. If there was a curve here, we're using the rectangles to estimate the area. Oh, dang it. Can I add trapezoid to this? Yeah. No, I said there's left, right, middle. There's one more that's even more accurate. We can do it tomorrow. It's really easy. Let's just get left, right, and middle figured out. None of these say to do it, right? Left, right, middle, left, yeah. Okay, so if we want to do this now, it just says using the right and left approximation, figure it out. So all you would do, I'm going to use a pencil. If I do the left approximation, my first rectangle, where does it go?
At 0.5.
It doesn't go. No, there's 0. You use the left. You got a picture. Here's each interval. So you use the left side of each interval to go up. So on the left of this one, my point was 0, 0. There's no rectangle there. The left of this one, I'll go up to here. On the left of this one, I'll go to there, right? See it? Left, left. So left that one. This one, I'll go to the left. So there's all my rectangles. Now you just do the area of all of them and add them up. They're all half wide, so I would do half. So my area is 1/2. And then just do the heights. Well, the height of that one, and I've got my list right here.
3 hours and 15.
And really, you didn't even need to draw the picture because you're just going to use 12, 18, 20, 14, 20. And just do it. 12 plus 18. 12, right? That one's 12 plus 18 plus 20. Oops, I don't know why I closed that. Plus. what
It's
was
May
that?
5th.
Plus, what, yeah.
14
See?
plus 20.
See how easy it is? What's that one? 14? And then that one was 20. That's it. Do the calculation, you'll have your answer. If they want, and then they ask for the right approximation.
Doesn't do everything the same, but one.
Yeah, just do everything the same, but on each interval. So in this box, I just start at the right. So this one right here, I'm going to go to the right and go up to the point. To the right, up to this point. Go to the right side of the interval and go up till you hit the point. And right side, so then you just do those boxes. wide, and then you're just like, oh, boom, 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 right? No, Pedro?
Does the first one count too?
Yeah, because this one, there actually is something there. So that one would be, same thing, it'd be 12, it would still be 18,
You just added another
20, yeah, there's just another 20 added. There's 6 of them now. This one, there was only 5, because that first one, there was nothing there. So that's it. So, yeah, like this one. This one, though, tells you 10 sub-intervals. So that's when you draw it. This is all in seconds, so every second you're going to have a thing. But on the last one, it just says 5 sub-intervals. So you're just going every 2 seconds, so you're making your rectangles wider. Does that make sense? Okay, and then this one's the same thing. Just, they gave you the table. Do it. 5 subdivisions. 1, 2. Oh, jeez, it's too easy. Too easy. That's all. Guess we can want to do trapezoid real quick. There's one more way. I'll just show you. It's not on your homework. I'll just show you, get it out of the way, because we have 10 minutes. Remember yesterday, t squared plus 1?
Yeah.
1, parabola. There's a more accurate way than left, right, or middle. Remember what a trapezoid is? No? Remember the definition of a trapezoid?
No.
One set of parallel sides, and then the other 2 sides are whatever. Well, guess what? I can draw in right trapezoids. Like that. Like that's a trapezoid. Remember how to find the area of a trapezoid?
It's like the area where it's squares and the person
1/2 height times
Base times height,
1
plus height.
Base 2.
Dude, calm down.
1/2 height times base 1 plus base 2. That's good old algebra stuff right there. So if I was doing this one, and I was doing the 0 to 6, 1, 2, 3, 4, 5, 6, I would draw in trapezoids for each interval. So like for this one, we would go, here's the base, here's my parallel sides going up, then I would have 1 point here and 1 point up here, and there's a trapezoid there. Ooh, that's a lot more accurate, isn't it? A lot less air gaps. There to there. It's not perfect, but it's way better. My picture isn't really that accurate. Point, and then there would be one more for 6, right? So then for the area of each one, well, they're all 1/2, right?
30 minutes to do 6
The height, which one is the height? No, in this case it's this way. These are all, they're all turned, heights this way, base 1 and base 2 are the tops and bottoms. Like if you did that one, the height is here, the bases are this and this. So these are all basically sideways. So when you do your area, they all have a half. They all have a height of 1. And then you would just have to, right, I'm just factoring out my half times height for all of them. And then you would just have to do base 1 plus base 2 for all of them. So, but this is kind of weird. So my first trapezoid,
60 minutes.
it's 1/2, the height is 1. Then this, base 1, how tall is that? 1 plus, how tall is that one? Oh, I gotta plug it in, right? No, I'll plug in 1. 1 plus 1 is 2. That's 2. My graph is not accurate. So 1 plus 2, right?
Mm-hmm.
This one then is 1/2 times 1. Then the height here is what? I have to use 2 again and this one. That make sense? Because to do the area of that one, it'd be 1/2 times 1 times 2 plus whatever that is. Plug it in, 5. So I would do 2 times 2 plus 5 times 2. And I'm doing times 2 because I know I'm going to use that one for this trapezoid too.
Oh my gosh. Aren't you using 5? Wait, why are you using 2?
Because there's 2, this is 5, right, this length, but I'm going to use it for this trapezoid, and I'm going to use it for this one. Because when I do the area of this one, it's going to be half times 1 times 5 plus whatever that is. I should have written it out. I'm doing it the quick way first. Really, you would do 1/2 times 1 times, this one would be 1 plus 2. Right? Plus 1/2 times 1 times, this one would be 2 plus 5. Plus, this one would be 1/2 times 1 times 5 plus, plug in 3, 9, 10.
So you're just pulling out the 1/2 times 1.
Yeah, this is the long way.
Everything together.
Just, yeah, I'm factoring out 1/2 and 1, because they all have the same, you all have half, because it's a trapezoid, and 1, because that's the height of all of them. And then this, I'm just kind of factoring it, 1, and then I use 2 twice, I'm going to use 5 twice. Does that make sense? I'm going to use 10 twice, I'm going to use this one twice, I'm going to use this one twice, and then I'm only going to use that one once. So you would put 5 times 2 plus, what was that, 10 times 2 plus, I plug in 4, 17 times 2, plug in 5, 26 times 2, and then 37. And I would do all of those, add those all up in there, times 1/2, and that would give me the area under the curve in the most accurate way possible. So you won't have to do that tonight, but that will be, I'll do it tomorrow. Okay. Good for you.
Oh my,
I need a sandwich.
it is hard. It says no
not
calculator
tiny.
rock these problems.
See my
It
point?
sounds like we will have to find a computer or something.
Yeah, man.